Welcome to section 7.3. This is functions involving e, and what we're going to be doing today are probably 3 or 4 kind of main ideas. We are going to be working on graphing, we're going to be working on simplifying, we're going to be working on another formula. We're going to be mixing kind of all of this stuff up. And so what I want to do is kind of slide this down, and we're going to try and get as much stuff in at once as we can. I want to start with this basic idea. What is E and where in the world does it come from? Okay, E is called an Euler number, and it's found, I'm going to start here by what it's found by. What we did is took that compound interest formula where we did 1 plus the rate R over N to the NT, and instead of our rate we made it 1 over N to the nth power. Okay, and we just made our time 1 and our rate 1. If we take this and we make n as big as we can, as n goes to infinity, so make n as big of a number as we can, what we found is that as n gets bigger and bigger and bigger, we start approaching this number called E. This number is 2.718281828, blah, 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 blah. And your calculator, it's like pi will never give you all of the digits in E, but it will approximate it. And what you want to know is that E is about 2.718. And that's kind of what you want to keep in mind. And so what we've done is we've asked you to use your calculators for the first part. And I want you to find your E button. And your E button, the one that I use is the division sign. So take a look at your graphing calculators and find your E button. What you want to do is say, okay, what's E to the 0.36 power? So I'm going to take in my calculator E and then use my caret key, 0.36. And I want to approximate this. And you end up getting 1.433329415. And I think that's what your calculator shows you. Now here's the problem. This decimal keeps going on. Okay? And so this is only an approximation. If you look at the second one, e to the negative 4th, I'm going to rewrite this a second because I know that negative exponents make reciprocals, and so I'm going to rewrite this as 1 over e to the 4th. Now, you can go back and put this in your calculator, but the question is, what do I get? Because it's a reciprocal, I know that my answer is going to be less than 1. What I end up getting is 0.0183156389. Dot, dot, dot. And I have to say dot, dot, dot because, again, this value keeps going. That's the only thing our calculator will give us. What I would like you to do is come in tomorrow with number 3 on your own. Okay, that'll tell me if you can plug values in your calculator. So simple request, number 3 is on your own. That's the first idea. Can you use E in your calculator? Because we're going to have to use this for the equations that we're going to give you in the third part of today's lesson. In the second part, we're going to be using our exponent rules. So chapter 5 and 6 are coming back again. Our exponent rules say that if we multiply powers with the same base, we add their exponents. So I end up taking 9 plus 6, and I get e to the 15th. I don't want you to evaluate. There's a difference in evaluate, which means plug it in your calculator and get me a decimal answer, versus simplify, which means leave the base and add the exponents. Okay? So we're going to do the same type of thing, and I'm going to make these a little bit more difficult every time we go. But take a look at example 2. I'm going to walk you through exponent rules kind of one more time. This squared out front is going to be distributed to both the 4 and the e cubed. Well, if I take 4 to the second power, 4 squared is 16. If I take e cubed and square it, I multiply these exponents, so I get e to the 6th. I'm going to just bring the 8e to the 5th along. Okay, now this gets us back to chapter 5 and 6 again. As I look at this, I divide my numbers. So 16 divided by 8 is 2. And I subtract my exponents. So I have e to the 6 minus 5. And 6 minus 5 is 1. So really all I'm left with is 2 times e. Don't say e to the first, just say e. Okay, we're going to do that same idea for part B. This cubed is going to get distributed to the negative 10, which negative 10 to the third power is negative 1,000. And e to the negative 5x to the third, I multiply these and get e to the negative 15x. Now the only problem is that's not my answer because we never want to leave our answer with a negative exponent. So this e to the negative 15x is going to our denominator by our exponent rules. So I have negative 1,000 on top. And once it moves to the bottom, the exponent becomes positive. So e to the 15x. Okay, and again, we're bringing back all of these rules because for some of you, it's been an entire trimester off, and for some of you just did these rules, but I want to make sure everybody's back on the same page. That's the start of them. I'm going to do number 3 with you too. Normally I'd give you 3 on your own, but number 3 is quite difficult, so I want to walk through number 3 together. So let me slide this down. Let's take a look. What we want to do is simplify everything inside first. These are all multiplied, so I'm just going to multiply my numbers together. And 4 times 27 is 108. In the numerator, I have e to the 13th and an x. And on the denominator, 3e to the 7th, x to the negative 3rd. That's all being square rooted. Now, I'm going to pretend the square root's not there for a while. I'm going to deal with what's inside first. So I take the numbers and I divide, and I get 36. So 108 divided by 3 is 36. We talked above that if I have the same base, I can subtract their exponents. So 13 minus 7 is e to the 6th. So I have, okay, an e to the 6th. This is an exponent of a 1, so it's x to the first. And again, I'm going to subtract the exponents. So 1 minus a negative 3 is plus 3. You get x to the 4th, and I square root it. Don't forget that the square root is still there. Okay, so let's take a look. If we go back to chapter 6, we asked you to split this up. And I can split this up as the square root of 36 times the square root of, e to the 6th. Let me change that. E to the 6th times the square root of x to the 4th. You can do this multiple ways. I can tell you this first though, the square root of 36 is 6. Depending on your teacher depends on how you looked at this. The easiest way, in my opinion, is to do this. I'm going to rewrite a square root as a 1/2 power. So e to the 6th to the 1/2. If I multiply these two together, 6 times 1/2 is 3, so this ends up being e cubed. These are being multiplied together. Let's multiply one more time. Same thing, if I do x to the 4th and the square root is the 1/2 power, then 4 times 1/2 is just 2, so that's an x squared. Now you'll notice every single thing I have is outside of the square root, which is what we like. So here's our answer, 6e cubed x squared. Done. Now they're going to get more difficult as we go through, and I'm actually going to start the next class with a question like this. But this is, again, this is a tough one, and we're bringing back a lot of chapters 4, 5, or 5 and 6 back to make sure you still remember those. Okay? Let's go back up and do some of the formula questions, because those are a little nicer. And I'm going to do this. We're going to talk about this idea of compounded continuously. And if you see this word continuously, it's going to trigger its own equation. Compounded continuously looks like this. A equals PE to the RT exponent. And our short version of saying this is we're dealing with PERT. Now let's talk. P is our initial amount. Okay, so P is our initial amount. R is still our rate, and again, like it was before, our rate has to be a decimal. And T is also still our time. The hardest part about this, I'm going to switch my color a second, is when you stick it in your calculator, R times T has to go in a parentheses for your calculator to evaluate it correctly. Okay, so let me show you an example. You deposit $3,500 in an account. $3,500 is our value of A. I'm sorry, not A anymore. This equation says P. I apologize for that. Paying 4% interest. If I take 4 and again I divide by 100, my R is 0.04. It is compounded continuously. That says to us we are using PERT. What is the balance after 2 years? That's our time. So let's stick this into our equation. P is 3,500 times E, because it's continuously, to the, I'm going to put in parentheses, 0.04 times our T is 2. And you want to stick that in your calculator. Now, biggest part, and I'm going to be a stickler on this, we're talking about money. And when we round money, we go to 2 decimal places. So please make sure that when you're going and putting this in your calculator, you're rounding to 2 decimal places, and you're also including a dollar sign to tell me you're talking about dollars. You end up getting 37. That's not what I wanted to do. Let's find my eraser. $3,791.50. And again, we're rounding to 2 decimal places, so be careful there. Okay, one more. We deposit $4,800. That's our A. 6.5%. When you divide it by 100, my rate is 0.065. Compounded continuously means PERT. What's the amount after 3 years? That's my time. So 4,800 times E to the 0.065 times 3. We are going to approximate this because we're going to round a decimal. You should end up getting about $5,833.49. Now, if we're not sure about rounding, please make sure in class that you're asking how to round, because I will take points for every rounding error you have. This last one is an on your own question. This is, can you plug things into your calculator correctly? So take a look. They're telling you you have the length of a tiger shark modeled by the age, where T is its age. So what's the length of the shark at 4 years old? I'm going to give you a hint. Plug 4 in for T and tell me what you get. Okay, and again, I'm looking for how long it is. Let's go 2 decimal places in your calculator again. So this is due, this question here again is due before you come to class. We're going to move on to the second page where we're working on the graphing. So I'm going to slide some things around here a second. Okay, what I'm going to do is example 1 and 2 together with you. 3 and 4 are going to be our warm-up. And so these 2 are going to be our warm-up in class tomorrow. If you want to make sure that you're set for this lesson, I would so suggest that you try it before coming into class. And then when you come into class, you could work with somebody to double check. Okay? Now, if you look, we're looking at y equals e to the x, where e is now our base. Because this x value is positive, this is a growth. Okay, so this is exponential growth. If you look at number 2, that's different because it's negative x, so that means it's decay. And so we want you to recognize the difference first and foremost. If the exponent is positive with a base of e, it's growth. If the exponent is negative with a base of e, it's decay. Now, there's still like a value in front. This is like 1 times e to the x or 1 times negative e to the x. And that value of a still tells us that our y-intercept occurs at the point 0, 1. I apologize, my pen is acting up here, so let me try again. Okay, same thing in the second one, and we're going to kind of correspond these together. Because I'm not moving up or down, my asymptote still occurs at the x-axis, the y equals 0 line. Same thing here, there's no up or down, so my asymptote is at y equals 0. Now you could draw this in and say, okay, I have this point 0, 1. And you could draw this one in and say, okay, but I still have this point 0, 1. What you should notice is the difference in growth and decay. Growth, we said, started close to the x-axis and then maneuvered its way up, where decay started up and then went down closer to the x-axis. Now, domain and range are still the same. Domain, we said any exponential, your domain is all reals, because you can put in positives, negatives, and 0. And my range, take a look, my point is above my asymptote, so my range is all reals greater than 0. To find the remaining points on your graph, you're going to have to use your graphing calculator. So you could make a table, though, again, if you need, and use your E button, -2, -1, 0, 1, and 2, and find the decimals for it. But you end up, if I kind of approximate where these points are, you end up getting a growth graph that looks kind of like this. Okay, and you can plug in the values. This transformation, though, is none. This is called our parent function for growth as you look at it. But again, you're going to need your calculator for this section because you don't know E or how to do 2.718 to the second power. So obviously this is a calculator one. Let's talk about same or different with decay. My domain, it's an exponential, so my domain is still all reals. My y-intercept is still above my asymptote, so all reals greater than 0. This again is a base decay function, so there's no transformations. Again, if I wanted to find points, pick my trusty values of -2, -1, 0, 1, and 2. But you should find that it ends up being pretty similar to the graph that we had before, only it goes in the other direction. And I go start high and go down low. Okay, and so this is the idea. We want you to really see basically this stuff is what we've done in 7.1 and 7.2, only our base is E now instead of being either a value greater than 1 or a value between 0 and 1. Okay, so again, example 3 and 4. Give it a try. Please, whatever you do, try it. And then what we're going to do in class is actually verify, are we on the right page? I want you to look at it and say, okay, can you at least tell me this stuff? You know, the y-intercept, the transformation, the starting points, can you at least do that for me without actually having to graph it? If you can do that, we are doing very, very well in this section. Okay, so that's all for section 7.3. Thanks for watching. Again, bring your questions to class tomorrow.